All right, here we go. Boy, this is lesson 7, the last lesson of chapter 4. Hopefully you got your cup of tea or coffee or something. I don't know. Here we go. I'll go through these. I want you to take time, and you see in your book it tells you, oh, this should take you 5 minutes. Well, if it takes you 10, that's okay too. Think long and hard about them. Use all the skills you've built up over the past 6 lessons and your years of math, and do your best to answer them. And then I'm going to answer each one, and you can check mine out. Okay. So, and there's a few examples and solutions that your book gives for each one of these. So, first one, a ship sails 5 kilometers from point A, or port A, whatever, at a bearing of 85 degrees. Then goes another 6 kilometers at a bearing of 50 degrees. Find the distance and bearing from A, of where the ship is after it does those two things. So here we go. Let's gotta draw a picture, right? So here we go. Let's draw a picture. So here's point A. Okay, so you go ahead and answer this, please. Okay. Pause the video, draw a picture, get your distance and bearing from A of where the ship winds up. And then come back and see how you did it different than me. And if we wind up with the same answer, even though we did them differently, hopefully. Okay, here we go. All right. So here's my point A. This is the way I'm going to do it anyways. Yours might not be the same. Okay. But hopefully we end up with the same answer. So there's straight north is 0 degrees. So this bearings is set up different than the old unit circle. So something to get used to. So you're facing straight north. You turn 85 degrees. Almost 90, right? Almost 90. You turn 85 degrees and you go 5 kilometers. 5 kilometers, 85 degrees. Okay, then what? Then 6 kilometers at bearing 50. So let's draw another north, straight north arrow. I put an N up there, straight north. So I've got my compass. If you've never messed with a compass before, I was in the Army, so compass makes a lot of sense to me. If you've never messed with a compass, there's probably a compass app on your phone, and sure enough, you can hold it at 90. I mean, you can hold it at 0 degrees. Well, you're facing straight north, right? It'll say north on there, and you can turn that phone to 85 degrees, a bearing of 85 degrees. I'm sure you can find this if you really want to. A little app for north, south, east, west bearings and all that good stuff. So at 50 degrees, so it wouldn't be 45, it'd be half of 90 right there. So, right? So I'm just sketching 50 degrees. Gosh, that doesn't look right. My 85 is not 85. But anyways, so my sketch is not very good. Maybe your sketch is better. So there's 50 degrees right here. Very poor sketch. Because my 85 is more like a 75 or something, or 60 even. Okay, I'm sorry. And I go to this. This is my ship here. Here's my little boat. Anyways. And that's 6 kilometers. So my drawing is horrible. So I want to know on a straight line distance from point A, where am I? So it's important to have this idea that I've got these north bearings, and north is far enough away that these are parallel to one another, right? These lines are parallel. So now you got to go back to an old lesson you had, parallel lines. And when I have 2 parallel lines, so I'll draw that part a little better, I hope. So there's my bearing of 85, almost 90 degrees, right? So if this is 85 degrees, what does this measure right here? Remember, if I'm going, this is the way, if I turn around and go back the way I was going, then I turned 180 degrees. So I always think of it like that. Traveling down my parallel line, I hit my transversal, I turn, I got 85 degrees there. I turn again, I had to turn 180 minus the 85. 95 degrees right there. So this is 95 here. 95 plus 50, I'll redraw this triangle now. Maybe this will be a little better of the triangle. So this is it in here, my 95 plus my 50. That's still bad drawing, but this 95 plus 50 is 145 degrees. I got 5 kilometers and 6 kilometers. How far is this side? This distance here, right? Oops, I'm a little off the page. So, okay, I got two sides with the included angle, the angle between them. Ding, 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 ding. What does this tell me to do? D squared equals 5 squared plus 6 squared minus 2 times 5 times 6 cosine of 145. Oops, I went off the page. 145 degrees. So this problem, I know I've talked a lot and made it long, but it's not that bad of a problem. So then, of course, I see if I can put all this in. I got D equals the square root of 25 and 36. Is it 61? Anyways, I'll just 25 plus 36, 61. Okay, 61 minus 60 cosine of 145. Okay, let me put that in my calculator. See if I can do that all at once here. So I got the square root of, and it'll all be under there the way my calculator works, 25 plus 36 minus, one thing you're getting by doing all this is getting a little quicker so that when this test comes up, uh-oh, I got an error. What did I do wrong there? See, so I don't want to do that on the test. 25 plus 36 minus 60 cosine of 145. No error that time. 10.5. D equals, oh, and I didn't estimate before I did it. 10.5 kilometers. Does that make sense? Okay, let's see this. Does that make sort of sense? To me, it does, because this is 5 and this is 6, so it can't be longer than 11. It can't be 11. It can't be longer. But this angle is 145. Really, really obtuse angle. So this distance will be quite close to 11. Okay. So, oh, and then we need to know the bearing from A to here. How do we get that? How do we get that? We know it's going to be less than 85. Oh, I bet I know. Okay, so let's go with this here again. Now that we know that this is 10.5, this distance from point A to my boat, now what could I use? So this is part B. I want to know this angle right here, right? And then I can get this bearing angle, right? If I know that angle there, this is 5 degrees. There's other ways to figure this out, but this little angle in here is 5 degrees, and then this, and now I subtract from 90, I'll get my bearing right here, right? This is north again. So how do I get that angle? Well, one way would be law of sines. So I could go this angle that I want, whatever, let's call it angle A. So the sine of A over 6, the opposite sides, equals the sine of 145 over 10.5. My law of sines. So let's see, and then I'd multiply it over here. So A equals sine inverse of 6 times sine 145 over 10.5. All right. We won't be quite done after that, but you can see where we're heading, right? let's do it here. Let's clear our calculator. I should shift sine inverse 6 bracket sine 145, close that bracket. I don't have to do this here, but anyways, divided by 10.5, close bracket. Is there another bracket? I can't remember. Let's hit it. It did it. 19 degrees. A equals 19.1 degrees. Okay, so then our bearing will be, so that distance at a bearing of 90 minus 19.1, or I'm sorry, just go with 85. I was going to 85, right? So this is all how you seeing this. So 85 all the way to here, and then this angle we calculated now is 19.1. 85 minus 19.1 would get us, if I took away 20, it'd be 65. So 65.9. A bearing of 65.9 degrees. Okay, I hope that's what you got. If it didn't, hey, you might want to just rework the problem now on your own without looking at what I did, right? That doesn't hurt anything. You know, you've seen how it's done. Well, don't just skip over and like, oh, well, bummer, I missed that. Well, rework the whole thing again and get better at your drawings, because I know that's a big part of it. You know, my drawings are ugly, but they work good enough for me. Yours could be a little better, and that way you'll build up your speed answering these crazy problems. Okay, good luck with that, Kenda. And now we'll go on to number 2.